Mastering artificial neural networks. Neuron output and activation are not one and the same. Which specific distinction can be made between the output of a neuron and its activation in the context of artificial neural networks? In the context of artificial neural networks, a fundamental distinction can be made between the output of a neuron and its activation. While these two terms are often used interchangeably, they have distinct meanings and serve different purposes in the functioning of a neural network. The activation of a neuron refers to the output of the activation function applied to the weighted sum of the inputs to the neuron. In other words, it is the result of applying a nonlinear transformation to the weighted sum of the inputs, which allows the neuron to learn and represent more complex relationships between the inputs. The activation function, such as sigmoid, tanh, or ReLU, is used to introduce nonlinearity into the model, enabling the neuron to learn and represent more complex relationships between the inputs. On the other hand, the output of a neuron refers to the final output of the neuron, which is the result of applying the activation function to the weighted sum of the inputs. In other words, it is the final value produced by the neuron, which is then used as input to the next layer in the network or as the final output of the network. To illustrate the distinction, consider a simple neural network with one input layer, one hidden layer, and one output layer. Suppose we have a neuron in a hidden layer that receives three inputs, x1, x2, and x3, with corresponding weights w1, w2, and w3. The weighted sum of the inputs to this neuron would be z equals w1 by 1 plus w2 by 2 plus w3 by 3. The activation function, such as sigmoid or ReLU, is then applied to z to produce the activation of the neuron. The output of the neuron would be the final value produced by the neuron, which is the result of applying the activation function to z. Mathematically, the distinction can be represented as activation, A equals sigma, z, or A equals ReLU z. Output, y equals A. Where sigma is the sigmoid function, ReLU is the rectified linear unit function, z is the weighted sum of the inputs, A is the activation of the neuron, and y is the output of the neuron. In summary, the key distinction between the output of a neuron and its activation is that the activation refers to the result of applying the activation function to the weighted sum of the inputs, while the output of the neuron refers to the final value produced by the neuron. While the terms are related, they serve different purposes in the functioning of a neural network, and understanding the distinction between them is crucial for building and interpreting neural networks.